Good evening, everyone. Welcome to this FPGA Masterclass series. I warmly welcome you to the session. Thanks for coming and thank you for your time. First, I would like to welcome the early comers first. Hakim, welcome. Chima, welcome. Kamrul, welcome. Nidhi Verma, welcome. Shaukat, welcome. Vijay Prakash, welcome. PKC Chair, welcome. Okay. So, if I'm audible, just type yes in the chat box. If I'm not audible, just type no in the chat box. Okay. Zain, welcome. Shimran, welcome. Rathar, welcome, and Sharmila, welcome. Krishna, welcome. Extar, welcome. Hazan, welcome. Siddhant and Zitin, welcome. Harish, welcome. Dark, welcome. Swastik Kamath, welcome. Shonu Sharma, welcome. Bimala, welcome. Rohit, welcome. Divya, welcome. Okay. So thank you so much. Thank you so much. Deepak, thank you. And KLDS, thank you. Okay. Kesaman, thank you. So, why 21 days challenge? Okay. So in Pantech, we'll be conducting 30 days challenge as well as 21 days challenge. Because all our program will have both skill set as well as mindset. Okay. One slide is dedicated for mindset because we strongly believe that mindset is essential for your success. So we will be dedicating one slide for mindset. The rest of the slides will be on skill set. Okay. To form any habit, you do anything consistent for 21 days or 30 days, it becomes a habit. Okay. So we want self-learning as a habit for you. That's the reason we kept this challenge for 21 days or 30 days challenge. Okay. So what we'll be learning on this 21 days. Okay. So day one, it is on introduction to FPGA, where we'll be covering up why you have to choose an FPGA for embedded system design. Okay. And how to, what are the parameters you have to consider while choosing an FPGA, and the history of FPGA, and what are the tools which you require for an FPGA design. So that we'll be covering up on day one. On day two, we'll be covering up the hardware description language. Okay. So we have we are covering up VHDL on this program. We have not covered up Verilog. We are covering VHDL, C language, and Python. Okay. So day two, introduction to VHDL and how to create a project in Xilinx ISC. And day three, operators and data flow modeling. We'll be covering up operators and data flow modeling. And day four, how to write a simple program for structural and behavioral modeling. Okay, on day four. And day five will be covering up how to create a test bench. Okay. So day six, how to design an FPGA board. We'll be using a Spartan 6 FPGA design board. You can use the same thing for Artix or for Zinc series. Okay. So day 6 is how to design a Spartan 6 FPGA board. Day 7, we'll be covering up how to write a simple LED program, okay, and how to interface an LED with an FPGA, and how to interface switch and relays and buzzer to an FPGA, and how to program. We'll be covering up the VHDL program. We'll be going through the program step by step. And day 8, we'll be covering up UART programming. Okay, how to write a simple UART program. What is UART? And how to write a simple UART program on FPGA. And day 9, we'll be covering up LCD programming. How to interface LCD 16:2 LCD for display. And day 10 will be covering up ADC programming, okay, analog to digital converter programming on FPGA. And day 11 we will be covering up of home automation using FPGA. We'll be interfacing a HC05 Bluetooth module to an FPGA, and we'll be turning on and off relays, okay, by using your smartphones. That we'll be covering up on day 11. It's a project. Day 12 is also a project. We'll be covering up Internet of Things, like how to interface Wi-Fi with FPGA, ESP8266 with FPGA. So day up till day 14, it's about VHDL program. We'll be using VHDL program. From day 13, part 2, like Internet of Things, we'll be reading the temperature and sending to the ThinkSpeak cloud. Okay. So day 14, we'll be covering up the motor control using FPGA, and day 15, we will be covering up how to write a C program for an FPGA, how to use Xilinx Platform Studio. Okay, how to do an embedded system design using FPGA. We'll be using a Microprocessor processor, how to port Microprocessor processor, and how to write a simple LED program using C language. Okay. Day 16, we'll be covering up median filter, like image processing application, how to apply median filter, how to remove salt and pepper noise from an image. That we'll be covering up. It's a project actually. Day 17, we'll be covering up edge detection using FPGA. So 16 and 17 are based on the C language. Okay, C language, and the core is Microblaze. And day 18, we'll be covering up IoT programming using C language. Okay, so day 19, we'll be covering up how to debug FPGA by using Chipscope Pro. Day 20, introduction to Python programming on FPGA. And day 21 is YOLO object detection, how to run a machine learning algorithm on an FPGA. Okay, so YOLO stands for you only look once. So how to run a YOLO object detection on FPGA. So these are the things which you are going to cover up on this 21 days. I hope you have a great learning. So thank you so much for your time. So no need to type present sir in the chat box. So we'll be issuing an attendance certificate at the end of the session. So you could submit the attendance. Okay. So no need to type the attendance present sir. No need to type present sir in the chat box. Okay. So thank you so much. If you are ready to learn, just type RTL in the chat box. RTL, ready to learn in the chat box. Okay. So I'll give a short introduction about Pantech and about me, and then we can go for the session. So Pantech, we basically manufacture microcontroller boards, DSP boards, and FPGA boards. We do also manufacture a lot of trainer kits for electronics as well as for electrical engineering. So if you want to know more about our products and services, just log on to our website, pantechsolutions.net. Okay, our vision is to help 10 million students to learn the technology in an easy way. So far, we have trained 2 lakh plus students on YouTube. So this year we'll be targeting of training around 4 lakh students on YouTube. We have a lot of upcoming programs. Please do subscribe to the channel so that you will get an update whenever we launch a series. Okay, so the next series is on embedded system design using Cortex M4 series, which is again a 30-day series. So and ML machine learning masterclass series. So please subscribe to the channel so that you will get notification. This 30 days is free. Okay, this 21 days is free. About me, my name is MK Jeevarajan. If you want to, I have my LinkedIn link in the chat box. If you want to connect with me, you can connect with me. Like, I'm happy to help. I completed my bachelor in the year 2002 from Government College of Engineering, Bagu, and my master's degree in the year 2004. So my primary expertise is on microcontrollers. Okay, I used to work on various microcontrollers. I used to design boards. I head the research and development team in Pantech, and I have designed more than 300 plus products on Pantech. I have around 18 plus years of experience. I have worked on various FPGAs like Spartan series, Vertex series, and Zinc series, and DSPs. I have worked on both analog devices as well as on Texas Instruments. So this session is about sharing my knowledge with you. So if you want to connect, I'll share my LinkedIn link in the chat box. I'm happy to connect and happy to help. Just give me a moment. Let me share the LinkedIn link. Okay. Okay. So So this program is basically based on embedded system design. So based on embedded system design. So coming to the announcement, the attendance link will be available at the end of the session. So we will be providing an attendance link during the live session. So you have to submit the attendance form, and the attendance form will be closed during the live session. Okay, it will not be extended. So it will be closed. So will be kept open for 30 minutes or 1 hour. After that, it will be closed. Okay. So minimum attendance required to get a free e-certificate is 18 days. Okay. So we have wait of 3 days if you're not able to present due to some reasons, but you need an attendance of minimum 18 days. Please do fill the attendance form correctly, because the certificate generator will take the name only from what you have filled. If you got the certificate name wrongly, then it means you have typed the attendance form wrongly. You have to please, whenever you type the name and the college name, please do type it correctly, okay, without any spelling mistakes, because the software fetches from the form which you have typed. Okay, there is no manual work involved. So if you get the certificate wrong, then it means like you have typed the form wrong. Okay, for internship candidates, no need to fill the attendance form. All you have to do is, after watching the video on the portal, you'll be given access to a portal. After watching video on the portal, you just give complete and continue on the top. Okay, so that will mark the attendance. So we'll be using recorded video streaming for lab classes to improve the learning experience, and videos will be removed from YouTube after 3 to 5 days. Okay, so if you want to revise, or you have to go through the videos within 3 to 5 days. Okay, so let's start the day with the mindset lesson today. So today mindset lesson is about the form is from Jeevarajan. Okay, so the formal education which you get from college will get you a job. If you want to become rich, or if you want to make more money, then self-education is the best thing which you have to have. Okay, you have to learn on daily basis on various things, like you should have learnings on finance, you should have learnings on marketing, sales. Okay, how to market yourself, how to develop yourself, because more you work on yourself, what the impact will be. Okay, so self-education. So if you want to become rich, or if you want to make more money, you have to work on yourself. You have to upgrade your skill set, you have to upgrade your mindset. Okay, you have to upgrade the skills necessary for the high income skills necessary for getting higher pay. Okay, so this is the code which I like to share you today. Let's go for the session. Okay, so if you are ready to learn, just type RTL in the chat box. RTL in the chat box. Thank you, Giridhar. Thank you, Anshul Gupta. Thank you. Okay, Ovais Hasan. Thank you. Durga Prasad. Thank you. Okay. So Mohit Patel, the ML masterclass will be on the next Monday. Will start on next Monday. Okay. Okay, ready to learn. Okay. So thank you. Thank you so much. Okay. Ripul, Amit, thank you, and Osama, thank you. Pradeep, thank you. Okay. So why FPGA? There are a lot of processes. If you have attended the embedded masterclass series, I have repeated the same thing. There are a lot of processors and controllers available in the market. Why is FPGA so special? Okay, so let's go for the why factor first. Why you have to learn FPGA, and why you have to choose FPGA for embedded system design. Okay. FPGA stands for field programmable gate arrays. Okay, when you go for the various controllers and processors, you have microprocessors, you have microcontrollers in the market, like 8-bit microcontrollers, 16-bit microcontroller, 32-bit microcontrollers, and you have the digital signal processors. Okay, you have digital signal processors, you have CPLDs, complex programmable logical devices, and you have FPGAs, field programmable gate arrays. You have general purpose processors like CPU, Intel Pentium 4, CPU. You have GPUs, graphic processing unit, and you have ASIC, application specific integrated circuits, and you have TPUs, okay, tensor processing units, and system on chip. So these are the different types of processors and controllers available in the market. And what is so special on FPGA? Okay, so FPGAs. Dharmendra, I'll just come to your point. Okay, what is FPGA? I'll come to the. I'll come to a point. Okay, so you have different types of processors and controllers, and there are a lot of manufacturers who manufacture these microprocessors and microcontrollers. If you take microcontrollers, you have Dallas, Philips, like NXP, Renesas, Texas Instruments, Microchip. These are the companies who manufacture these microprocessors and microcontrollers. Okay. If you know the difference between the microprocessor and microcontrollers, then you can choose the right processor for your embedded system design. Okay. The DSP processors, you have Texas Instruments and analog devices, which was dominated. The market was dominated by Texas Instruments and analog devices. And CPLDs and FPGAs, the market is dominated by Xilinx and Altera. Okay. Xilinx is now acquired by AMD, and Altera has been acquired by Intel. Okay. And general purpose processors, market is dominated by Intel, and you have ASIC, and you have for GPU like NVIDIA is there. Okay. And TPU like Google Coral is there, a tensor processing unit, which is specifically for embedded, for machine learning applications for embedded processors. Okay, so these are the processors available in the market. We will go one by one, like what is the difference between a microprocessor and microcontroller, why you have to choose an FPGA. Okay, so is that clear? Is that clear till this point? If it is clear till this point, just type clear in the chat box. If you want me to repeat, just type repeat in the chat box. Okay, I'll go through a chat. I'll wait for 20 seconds. Your answer will reach me within 20 seconds. Okay, so if it is clear, just type clear in the chat box. If you want me to repeat, just type repeat in the chat box. Okay. Okay. So Sharma, like I'll come to your point. What is CPLD? I'll come to your point. Okay. So Stik, thank you. Saurabh, thank you. Lavakumar, thank you. Okay. Kanika, thank you. Saravanan, thank you. Yash, thank you. Okay. So thank you. So let's start with microprocessor. Okay. So what is a microprocessor? Like 8085 and 8086 series, like as an example for microprocessor. Microprocessor basically have a CPU as a separate chip, separate integrated circuits. Okay, we'll have a CPU as a separate integrated circuits, have memories as a separate integrated circuits, and all the peripherals like like UART peripherals, okay, and timers, RTC, all these peripherals will be as a separate chip. You need to do a PCB design to integrate all those chips. Okay, so that is the disadvantage of microprocessor, but like it is expandable. You can expand the capabilities of microprocessor. Okay, I just repeat. So let me show this. Okay, let me show an example for let me show an example for 8085 kit. Okay, so this is an example for microprocessor. Okay, so you have separate ICs. Okay, you have 8085, everything. Memory is a separate integrated circuits. You need to do a PCB design in order to make the functionality to work. Okay, so that is the disadvantage of microprocessor, but it is expandable. Okay, whereas in microcontroller, everything is on chip. Okay, you have the CPU, you have the peripherals like UART, program memory, data memory, timers, ADC, controller area networks. All these peripherals are available on a single chip. Okay, whereas there in microprocessor, you need to have a separate chip for each and every functionality. You need to do a PCB printer circuit board design, okay, in order to integrate all the ICs. So that is microprocessor. So microcontroller, since it is available on the same chip, the functionality is limited. Okay, it has limited program memory, this has limited data memory, the function limited GPIOs, and limited peripherals. But you can use for embedded system design. Okay, when you design for an embedded system design, microcontroller will be a very good option when you choose microcontroller. Okay, so is this clear? The difference between a microprocessor and microcontroller is clear for you. Just type clear in the chat box. The difference between a microprocessor and microcontroller is clear for you. Just type clear in the chat box. I'll go with the majority. Okay. Okay, I will reduce my, Manjunath is asking to reduce the video size smaller. Okay, let me reduce the video size smaller. Okay, so, okay. We will be using, Sharma will be using, Samir Sharma will be using VHDL, okay, not Verilog. Okay, so thank you, Mohan, thank you, Anshul Gupta, thank you, Danush, thank you, okay. Jitu is asking for repeat, okay. So Jitu, like the video will be available on YouTube for 3 to 5 days. Okay, so please go through the video. It's very simple. A microprocessor, all the peripherals. Okay, peripherals. I mean the peripheral means like the GPIOs, the UART, timers. Okay, so everything you have like program memories, program memory and data memory. Everything you need to have an external chip. Like it will be an external chip. You need to integrate to make the functionality work. That is microprocessor. Whereas in microcontroller, everything is available on a single chip. If you take an 8051, you will have the CPU inside, you will have the UART inside, okay, program memory inside, data memory inside, okay, on a single chip. So you can reduce the complexity of the PCB design. So that is microcontroller, but it is limited. Okay. So the basic features coming to DSP processor, digital signal processors. So when you go for digital signal processors are meant for performing complex mathematics. Okay, microcontrollers cannot do a complex mathematical model, whereas DSP processors are meant for processing complex mathematical calculations. It has MAC capability. Okay, multiply and accumulate. MAC means multiply and accumulate. It also has a capability to process infinite continuous data streams. Okay, like you can interface a camera, you can interface a mic to a DSP processor, and you can take the signals in real time, and you can you process the signals in real time. Okay, so that that capability you have it on DSP, where the microcontroller it does not have the capability of the DSP, okay, mathematical model. Okay, so DSP processors are processors designed for efficient mathematical calculations. Okay, so when you have you can choose DSP processor like whenever you need higher precision, whenever you want to save the cost, smaller in size and low power, because this process will operate at 3.3 volt. Okay, so when you compare this with a GPU, general purpose processors like Pentium 4, where you can wherever memory is not a constraint, and space is not a constraint, then you can go for GPP. Okay, but when you want to implement an embedded applications, then you can go for DSP processors. So the advantage of DSP processor is you can do an efficient mathematical calculation, okay, complex mathematical. It has the capability of doing floating points and fixed points. Okay, so you have floating point DSP, which has the capability of doing floating point operations, which will give you a higher precision. Okay, higher precision. So that's the advantage of DSP processors. Okay. So coming to CPLDs, complex programmable logical devices, and FPGAs. Okay. CPLDs are control oriented. Wherever you use a microcontroller, you can use a CPLD. Okay. Wherever you use a DSP processor, you can use an FPGA. FPGA or data path oriented. You can if you want to solve a complex mathematical calculation, you can use FPGA, field programmable gate arrays. Okay, field programmable gate arrays. So the advantage of going with FPGA is reconfigurable. I'll give you an example what is reconfigurable. Okay, you can customize the components which is inside the chip. You can customize the peripherals. You can customize the core. You can customize what you want. Okay, whereas in micro DSP processors you cannot do that. It's ready-made. Okay, whereas this is tailor-made. You can have your own peripherals inside the FPGA, whereas in DSP processors you cannot do that. Okay, once it's you cannot modify the peripherals, you cannot modify the processor core inside and DSP processor, but in FPGA you can modify. Okay, is a difference between CPLD and FPGA and difference between DSP processor and microcontroller is clear? Just type clear in the chat box. Okay, if you want me to repeat, just type repeat in the chat box. I'll go with the majority. Okay, I'm waiting for the chat. Mersha, thank you. And Madhumita is asking for repeat. Okay. So I'm waiting for a chat. If the difference between CPLD and FPGA is clear, and difference between DSP processor and FPGA is clear, just type clear in the chat box. Okay, Mayuri is also asking for repeat. Sorry, Gaming Hub is asking for repeat. Okay, okay, Pradeep is asking for repeat. Okay, okay, I see a lot of repeat here. I just give a concise repeat. Okay, so if you take a DSP processor is meant for solving complex mathematical calculation. Okay, so it is designed for the chip has been designed as a special peripheral interface to interface high-speed ADCs and DAC. Okay, because when you interface an audio codec or video codec, you need a high-speed ADC and DAC, and you should have a special peripheral interface for doing the operation. DSP has that special peripheral interface, and it has the capability to process infinite continuous data streams. When you interface a mic, okay, for audio, or when you interface a camera, or like this data will be generated continuously. Okay, DSP has the capability to process the data, because it has the core has the MAC capability, multiply and accumulate in a single instruction cycle. Okay, MAC means multiply and accumulate. Okay, so whereas in microcontroller, there are some microcontrollers, the latest microcontrollers from Cortex series, Cortex M4 series has some DSP capability, the ARM series has DSP. But when you take a dedicated DSP processor, it will give you higher performance than a microcontroller. Okay, so when you take an FPGA, FPGA, wherever you use DSP processor, you can use FPGA. Okay, field programmable gate arrays. So FPGA is also capable of doing complex mathematical calculations. Whereas CPLD, complex programmable logical devices, they are not capable of doing complex mathematical calculations. So wherever you have the functionality of microcontroller, you can do the same thing on CPLD. But one advantage of CPLD is it is tailor-made. You can customize the peripherals inside. Okay, for example, you take an 8051 microcontroller chip. It has a single UART. Okay, if you want another UART, then you need a software UART. Okay, you may include like 2 or 3 software UARTs. But if your application requires 10 UART on a single chip, then you can go with a CPLD. You will have GPIOs where this IO pins can be customized for your own use. The user can customize. Whereas in 8051, you cannot customize the pin. Okay, so once you have to go through the data sheet, and the peripherals cannot be customized. You may implement some software logic to perform the same operation on a GPIO, but you cannot customize the architecture, you cannot customize the peripherals which is inside the chip. Whereas in CPLD, you can customize. Okay, so that is tailor-made. And FPGA is also same thing. Wherever you use a DSP microcontroller, you can use FPGA. Okay, but it is tailor-made. You can customize the peripheral inside, you can customize the core, everything which is inside the FPGA. Okay, so is that clear? The difference between CPL and FPGA is clear? Just type clear in the chat box. I'm ready for a chat. Okay. So Rajkumar, UART stands for Universal Asynchronous Receiver Transmitter. We'll be covering up later. Okay. Praveen, there are few processors, like few chips. Praveen is telling like ARM Cortex has CPLD capability. There are few piece of the chip from the Cypress Semiconductor. They have the CPLD core inside. I'm not sure about which series there are, because the lot of companies are manufacturing ARM Cortex M4. I'm not sure about which series you're talking about. So thank you, thank you so much. Okay, let's go for the technologies. Okay, FPGA technologies. So based on the programming technologies, you have different types of FPGA. Okay, SRAM based technology, where it is reprogrammable, but it is volatile. Volatile means like whenever you switch off the power, the program on the FPGA will go off. Okay, like you have to reprogram again for once you switch on, like you have to reprogram again, or you need to interface a PROM, okay, to have a non-volatile memory. So SRAM based technology, most of the FPGAs are SRAM based technologies. And you have flash based technology, like which is volatile or which is non-volatile, where the program will be remain even when you power off and power on. Okay, so flash based technology is there. Spartan 3AN. So N stands for non-volatile. Okay, and antifuse is one-time programmable. It can be programmed on the fab, or the user can program, but it can program only for one time. Okay, mostly toys like there are some cheaper FPGAs which is used on toys. Okay, antifuse which is not used nowadays. So the most popular are SRAM and flash technologies. Okay. Flash SRAM is volatile, where you have to reprogram every time. Okay, when you switch on. Whereas flash, like the program will remain even when you power off. Okay, so coming to DSPs and FPGAs. Okay, so if you take if you take a DSP processor, we'll be using C language inside a DSP processor, and C language is basically a sequential language. Okay, whereas FPGA will be using hardware description language. The hardware description language will support parallelism. Okay, so if you take a simple FR filter operations, like if you implement the same thing on a DSP processor, it requires 256 clock cycles for performing the operations. Okay, whereas when you implement the same thing on an FPGA, it can complete the 256 operations on a single clock cycle and execute on parallel. Okay, provided the algorithm should support parallelism. The algorithm supports parallelism, then FPGA, the performance of FPGA will be much more higher than the DSP processor. Okay. Just repeat, DSP is sequential. Okay. DSP processor is sequential. So whenever you want to implement an FR filter or filter applications, like the MAC unit, you need 256 operations for completing, like it needs 256 clock cycles for completing 256 operations. Okay, whereas on FPGA, the algorithm is parallel. it can be completed on a single clock cycle. Okay, so performance is much more higher than a DSP processor. When you when you compare FPGA with DSP processor. Okay, so FPGA will support fine-grained parallelism. Okay? For example, if you take an example of this gravitational force, okay, if you want to implement this formula on a CPU, the traditional CPU will take 8 cycles. Okay, 8 cycles to implement these operations. Whereas by parallelism, you can reduce to 4 cycles and 3 cycles. Okay, where FPGA has the capability of implementing parallelism. The key thing is FPGA, you can do a efficient parallel processing inside an FPGA. Okay. So whereas in DSP processor, it's sequential. Not to compete with the FPGA, there are other processors. The DSP processor, they came up with the dual core processors. Okay, having more than one core inside an DSP processor. I will explain you later. So FPGA will support parallelism. Okay. So whenever you require higher performance, okay, whenever you have a parallel algorithm and FPGA will give you higher performance, you can customize the design. Okay. You can customize the design. By customizing your design, you can reduce the number of chips for your embedded system design. Okay. I'll show you one example, like what is like how FPGA overcomes produce better results than a DSP processor. Okay, in the upcoming slides. So you can reduce the number of chips so that you can reduce the schematic design, you can reduce the PCB design. Okay, you can avoid signal integrity issues. Okay. So is that clear so far? 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 Just type clear in the chat box. If you want me to repeat, I'll just type repeat in the chat box. I'll go through the chat. Okay. GPU, how is GPU different from, Praveen is asking like, how is GPU different from GPU? Okay. GPU stands for graphic processing unit. Usually initially it was used for rendering for video applications, for video gaming applications. But nowadays GPUs are used for deep learning and deep learning applications. Like whenever you use higher, more number of computations, you can use GPU. But GPU cannot be used standalone. Okay, you need a CPU. You need a CPU. GPU can be used along with CPU so that you can deploy the computational task whenever you apply a training algorithm, like deep learning training or machine learning training algorithm. You can deploy that on a GPU. Okay, instead of CPU will not have much more computation power when you deal with the image and video processing. So, but GPU cannot be used standalone. You have to you need a CPU so that the CPU deploys the computation task on the GPU. This answer is for Praveen. Okay. Okay, so this is one example for DSP processor. Okay, it uses TMS 320C671 series. It's a starter kit. Okay, so if you check the block diagram of this kit, you have the power supply unit. Okay, you have the CPU and you have the audio codec to interface with audio, to interface with mic, and and you have SRAMs and SDRAMs. Okay, for memories, and you have UART, timers, intercontroller. So the power supply unit, okay, the power supply unit, you cannot like the regulator, the voltage regulator ICs, you cannot have the functionality inside an FPGA. Okay, so you can remove the power supply unit. So the audio codec will have the analog ground, analog signal processing. So FPGA is purely on digital. So it's not recommended to have an analog signal processing inside the fabric of FPGA. So audio codec you cannot keep. Okay. So other interface connections like extra expanded GPIOs you cannot have. So all other SRAMs and SDRAMs, okay, SRAMs memories will occupy more silicon area. So you cannot have this logic inside SRAM logic inside the FPGA. Okay, that will occupy more logic cells. So SRAMs and SDRAMs you can remove. So the rest of the part, okay, the rest of the chips you can have a single. You can design it on a single FPGA. So the rest of the part which is not inside, you can have it external. By this way, you can reduce the number of chips. Okay, you can reduce the number of chips. You can reduce the complexity of the schematic design. You can reduce the complexity of the PCB design. Okay, So and you have, since everything is inside the chip, so the signal integrity issues will be less when you compare with the previous DSP design. Okay, so this is an example for reconfigurable. So the user can customize accordingly for their own use. Okay, so that's the advantage of FPGA. So is this clear? Is this clear? Like, is that clear? Like how you can reduce, how a chip can be customized inside a FPGA? Is that clear? Just type clear in the chat box. If you want me to repeat the slide again, just type repeat in the chat box. Okay. Rajiv, thank you. Fatima, thank you. Kushman, thank you. Shivashakti, thank you. Okay, is that clear? Just type clear your. Nilesh is asking, does it have OS? Yes, you can have operating system inside an FPGA. You can customize, you can have. Vaibhav is asking for repeat, okay? Okay. So Shridant also asking for repeat. So I'll go with the majority, like the video will be there. Please go through it, okay? So difference between Verilog and BHL is ADA-like language. Okay, Verilog is C-like structure. If you are comfortable with C language, you can choose Verilog. This answer is for Logesh. Okay. Performance-wise, both are same. Okay. Okay. So there are one more processor called SoC, system on chip. Okay, multi-core processors. So most of the DSP manufacturers, in order to compete with the FPGA market, they came up with the concept called having more than one core. Okay, instead of having one core, like they can have two core processors, two core on a single package, so that you can deploy simultaneously, so that you can use DSPs for parallel processing. Okay, when one core is taking care of one application, the other core will taking care of the other applications. If the core is same, then it is symmetric multiprocessing. If the core is different, then it is asymmetric multiprocessing. Okay. One example is TI OMAP. Most of your mobile phones now have four-core processor. It means four cores are there. Okay, you can simultaneously deploy applications for every core. So that will give you higher performance, like the process SoCs from Snapdragon, like from Qualcomm chips and Broadcom chips. Even ESP32, ESP32 has a dual core. Okay, ESP32 has a dual core processors. So this example is TI OMAP series, Open Multimedia Application Platform. Most of the mobile phones, which is in 2012, they use this chipset, TI OMAP series chipset. But nowadays the chipsets are based from Qualcomm's and Broadcom companies. So it has two cores. One is the ARM core, the other is the DSP core. So the ARM will take care of the GUI applications like the touch screen, touch panel, GPS. Okay, whereas the DSP core will take care of the audio applications, the camera applications, the mic applications. Okay, speaker and everything. So everything is on chip. Okay, no need to interface anything. You have GPS on chip, GPS. You have wireless LAN, Wi-Fi interface. You have Bluetooth. You have telecommunication chipset. Okay, UART, and you have audio codec and USB OTG, SPI peripherals like MMC card. Okay, MMC card, camera module, GPIOs, I2C peripheral, battery. Everything is on a single chip. Okay. So this is one example of system on chip. Okay, system on chip. So system on chip. So let us check for one more chip. IC is called ASIC, application specific integrated circuits. Okay, where these ICs are manufactured only for specific applications. One example is Intel Movidia stick is one example for that. So that chip will, if you give the program, if you give the chip design, if you provide the bit file to the manufacturers, the chip manufacturers, Xilinx or Altiron, they will manufacture the chip only for that bit file. Okay, so that is called an ASIC, application specific integrated circuits, which will do only that applications. You cannot use it for the other applications. It is not general purpose. But when you this will work only when you have large number of quantity. Okay, especially when you manufacture a product and you have 10,000 pieces, like 1 lakh pieces or 10 lakh pieces, 1 million pieces to be sold, then you can think about ASIC to reduce the cost. Okay, and it also gives the same performance on as like an FPGA, whereas FPGA is field programmable. Okay, so you can customize by the ASIC cannot be customized by the user, whereas FPGA can be the fabric can be customized by the user. The fabric can be programmed by the user. Okay, so that's the difference between ASIC and FPGA. Okay, so this is the comparison. Like you have, if you want to implement a simple door lock, okay, simple door lock, you can choose a microcontroller. No need to go for an FPGA or a DSP processor. Okay, for simple application like which the cost will be, you can get microcontrollers for even for 20 rupees, an 8-pin microcontroller. Okay, and you have 40 rupees, 81 you can get for 40 rupees. Okay, so if you want a simple complex applications, you can use a microcontroller. Okay, and if you have like if you have a complex mathematical model like audio processing, then you can go for a DSP processor. Okay, the cost, again the cost will be like, it comes around like, it varies from 500 rupees to like $10 to $30, $100, depending upon the IC which you choose. Okay, then comes the system on chip, like SoC, the performance will be much more better than the DSP processor. Okay, and ASIC will work only when you have large quantity. Okay, the performance will be high compared to an FPGA. Whereas FPGA, it's meant for, FPGA is meant for a hard real-time systems. Okay, like when you design a nuclear hard real-time system means like whenever you design a real-time systems like if the system misses some deadline, it may cause an havoc. Okay, so that is called hard real-time systems. One example is nuclear reactor. Okay, nuclear reactor and aircraft is an example. So that kind of systems you can use FPGA, field programmable gate arrays. Even a single chip will cost you, there are chips available for 10 lakh rupees and 20 lakh rupees. A single chip will cost you around 10 lakh rupees and 20 lakh rupees. You can visit a site called digikey.in. I will show you a site called digikey.in, okay, or digikey.com. So you can check out the pricing of various microcontrollers and so digikey.in is basically a supplier website. You can download data sheets, you can download the schematic symbols, okay, everything here. So please use this website called digikey.in, where you just type FPGA, it will give you the list of FPGA which is available in the market. Okay, there are totally 23,000 different types of FPGAs are there, and these are the manufacturers. You have Actel, Altera, Xilinx, Atmel, okay, Intel, Microchip, Microsemi. Microsemi has been acquired by Microchip. Okay, so these are the different types, and like you have based on this, based on the logic CLBs, based on the logic elements, based on the IOs, based on the gates. Okay, so these are the, and you can also see the pricing of the chips. Okay, if you check, this pricing is almost 10,000 rupees. Okay, 10,000 rupees 946. 22,000. Okay, so you can download the data sheets. You can download the data sheet of this. So if you want to be an embedded system design programmer or an FPGA design, so definitely you should know this website called digikey.in. You have to visit this website, okay, where you can download the data sheets and the necessary components. Even if you want to purchase, you can use this. Okay. Okay. So is that clear? Is that clear? Just type clear in the chat box. Is that clear? The comparison is clear. Just type clear in the chat box. If you want me to repeat, just type repeat in the chat box. I'll go through your chat. Okay. So the attendance will be available at the end of the session. Please do wait for the attendance. Okay. So Lokesh, I think what is the difference between FPGA and microcontroller? Microcontroller cannot be customized, whereas FPGA you can customize. Okay, you can customize the peripherals inside the FPGA. Okay. Thank you, Shantosh. Thank you, and Adibel. Thank you, Aarti Sharma. Thank you. Okay. So thank you so much. Okay. So let's start with history of FPGA. Okay. So far we have caught up why FPGA. Okay, why FPGA matters, and how FPGA competes with the other other processors and controllers in the market. Okay, so let's go through the history of FPGA. Okay, history of FPGA, like it starts from the small scale integration. A small scale integration, like it means the number of gates inside an integrated circuits. Integrated circuits is 12. Then it is called small scale integration. Okay, the number of gates is between 12 to 100, then it is called medium scale integration. Okay, the number of gates inside the integrated circuits is 100 to 10,000, it is large scale integration. And VLSI is very large scale integration. If the number of gates inside the integrated circuits, okay, is 10,000 to 1 lakh, then it is a very large scale integration. Okay, and then comes the ultra large scale integration. The number of chips, number of gates inside these ICs is from 1 lakh to 10 lakhs. Okay, and giga scale integration is more than 10 lakhs. Okay. So the size of the transistors which is used to implement these logic gates is reduced. So according to Moore's law, the number of transistors on the microchip doubles every year. Okay, every year. They started monitoring from 1971, but I think but Moore's law is going to be dead over for the next within the next decade. So the number of but so far it has been doubled for every 2 years. Okay, the number of transistors inside the microchip doubles for every 2 years. So we have now we have 64 core processors, and like 128 core processors are there. So which has more number of transistors inside a single chip. Okay. So it starts from the FPGA. The history of FPGA starts from the programmable logical arrays, okay, PLAs, and programmable array logic. Then comes the PLDs, programmable logical devices. In PLDs, you have two types: SPLD, simple programmable logical devices, and CPLD, complex programmable logical devices. Then comes the gate arrays. After that, you get FPGA, field programmable gate arrays. Okay. So if you take a PLA, a programmable logical array, you have both the AND plane and OR plane are programmable. Okay, you can implement a truth table inside a PLA chip. PLA is nothing but a chip. It's an integrated circuits. It's an IC, but nowadays it is obsolete. Okay, you can program the AND plane and OR plane, and you can implement the truth table inside this PLA. Okay, there are a lot of languages are there. You can write programming based like parallelism language, CPL, which is not used nowadays. Okay, so PLA and like where you can program, you can implement the Boolean logic, whatever the truth table which you want. So that is the PLA. The program array logic is you have the AND plane is programmable and OR plane is fixed. Okay, OR plane is fixed. Again, you can use this is also same thing as like PLA to implement the truth table. Okay, so PLDs which has a combination of PAL and PLA as well as some memory, like the flip-flop, like flip-flops which can access a memory device. So it can store the information. Okay, you can store the data. So like by using antifuse like silicon SRAM technology or EEPROM technology or flash memory technology. And like the language is CUPL, which is based on the university, like Cornell University Programming Language. CUPL stands for Cornell University Programming Language. I'm not sure about the ABEL. So these are the languages which is used for PLD programming, and they have separate programmers. Okay, separate programmers. And hardware description language, you can use Verilog and VHDL for complex PLDs. Okay, these are simple PLDs. These are simple PLDs. You can use parallelism, ABEL, or CUPL. Whereas for complex CPLDs, they come up with a higher description language for complex devices. That is Verilog and VHDL. Okay, hardware description language. So CPLD, you have the parallel block. Okay, you have the IO block. If you check the internal architecture of a CPLD, complex program logic devices, you have the logic blocks where you can implement the logic. Okay, you have the IO blocks where you can connect these IO blocks to the IO pins, and you have the clock routing. Okay, and the routing matrix which is used to connect these logic blocks. There is no memory inside. There is no processor core. Okay, there is no processor core, and there is no peripherals. Okay, so you can there is no MAC capability. There is no DSP blocks inside the CPLD architecture. Okay? It has only logic blocks. So if you want to implement a simple microcontroller like 8051, if you want to implement an 8051 microcontroller inside a CPLD, that is possible. Okay, so you can implement that by using these logic blocks and IO blocks. Okay, so you can customize the internal core, the CPLD core. The user can customize on their own. So it does not have a core. It does not have the processor core. Okay, is that clear? Is that clear? Okay, whereas in FPGA, you have the logic blocks to implement the lookup tables and to implement the truth tables. Okay, and you have the IO blocks. Additionally, you have the core. Okay, you have the clock routing which is used to supply clock for this logic blocks, and you have multipliers and DSP blocks, which has the MAC capability, multiplay and accumulate. Okay, so you can, so this multipliers and DSP blocks can do the capability of a DSP processor, and additionally you have the core. Okay, additionally you have the processor core. This core, there are two types. One is the soft core processor, the other is the hard core processor. Okay, soft core processor means the core can be created by the user. Okay, the hard core processor, the core is created by the manufacturer. During the fabrication process itself, they manufacture the core inside this FPGA. Zinc is, for Zinc you have ARM core. Okay, that's a hardcore processor, and for Vertex you have PowerPC. Okay, it's a 64-bit architecture. It's a hardcore processor. Whereas Spartan 6 you have Microblaze 32-bit RISC architecture. It's a softcore processor where you can where the user can customize the core, and user can port the core inside the FPGA. Okay, so if you want dual core processor, still you can have two Microblaze architecture inside. Okay, and you can write the C program for that core. So we will have example. We will, in this challenge we will have an example how to port a Microblaze core to the FPGA. Okay, so is that clear? Is that clear till this point? This FPGA architecture is clear for you? Praveen, like SoC is used even if you take Raspberry Pi. The Raspberry Pi has SoC. Okay, your mobile phones has SoC. Okay. Okay. So attendance link will be available at the end of the sessions. At the end of the session, is that clear? Is that clear? Just type clear in the chat box. The CPLD architecture, the history of FPGA, the CPLD architecture, FPGA architecture is clear. Rajshekhar, thank you. Abdul, thank you. Softcore, okay. George is asking what is softcore. See, softcore means the core can be created by the user. Okay, for example, you want a 32-bit RISC processor inside an FPGA, you can customize by using the software. Xilinx has a tool called Xilinx Platform Studio, and like where even Vivado will also support, like where you can port the Microblaze core inside the FPGA, okay, through IP cores. So IP cores is nothing but intellectual property codes. All these are pre-written VHDL codes, VHDL or Verilog codes. So you have option to choose whether you want VHDL or Verilog. So the software itself will generate a code for the processor. Okay, that is softcore processor. The core is created by the user. That is softcore processor. Okay. Okay. So is that clear? So I'll just go through like what is the same thing what I said earlier, like basic FPGA architecture. You have the CLB blocks, okay, which can, the CLB can act as a gate and you can implement the lookup tables. Okay. The next thing is you have DSP blocks for MAC capability. You can do multiplications and additions on the MAC block, DSP blocks, and you have block RAM, which is used to implement memories. Okay, and you have the core, the hard core, the ARM core, PCI, Ethernet. These are peripheral. These are hard cores. Okay, and you also have soft cores. Okay, so coming to the conclusion, FPGA where you can use for FPGA, if you wherever you use DSP processor, you can use FPGA. Okay, and you can customize. You can customize the core inside. You can customize the peripherals inside. CPLD, wherever you use microcontroller, you can use CPLDs. Okay. So PLDs are not used nowadays. Like it is very rare to get the integrated circuits. But if you want to implement a simple truth table or multiplexers, you can choose PLDs, okay, programmable logical devices. So coming to the manufacturer, you have Xilinx. The popular is Xilinx and Altera. Okay, Xilinx has been acquired now by AMD, and Altera has been acquired by Intel. And you have Actel, Lattice, Microchip. They have Microsemi FPGAs. Microchip also manufactures FPGAs. Okay. So Xilinx portfolio, you have Spartan series, Vertex series, Arctic series, and Kintex series. You have Zinc. Okay, in 7 series, like you have Spartan 7, Arctic 7, and Zinc 7. Okay, Spartan is for IO optimization, whereas Arctic for mostly based on transceivers to implement high-speed transceivers, like for communication. Okay, and Rocket IOs. And Zinc is for embedded, for complex embedded system design. Okay, it has both hardware and software adaptable SoC. Okay, you can have complex embedded system design on Zinc. So is that clear? Is that clear? Is that clear so far? Okay, just type clear in the chat box. Okay, so today, like I think we're running out of time. Like I'll probably complete within the next 5 minutes. Okay, 5 minutes. So we will stick to the timings from tomorrow. Okay. So selection of package. So whenever you choose an FPGA, it also comes with you need to choose the package. Okay. Mostly FPGAs are available on quad flat package as well as on the BGA, ball grid arrays. Okay. So quad flat package can be mounted by using soldering station, whereas BGA, the ball grid arrays, you need a O1, which will be costlier, which will be higher cost. You need a stencil to do this. Okay. So whenever you design an FPGA board or FPGA development board or FPGA based embedded system design, be aware of the packages. Okay, and you should have knowledge on how to choose a package. So processor selection criteria based on the development tools, what development tool which you are going to use, and based on the number of IOs which you require for your embedded system design, and based on the speed like performance, and based on the cost, because FPGAs are available for 1,000 rupees and even for 10,000 rupees. Okay? And based on the operating system you want, okay, what kind of operating system you want, whether you want Windows CE or Linux based operating system, and hardware tools like whether you are going to have a quad flat package or a ball grid array. Okay, so based on the hardware tools and based on the peripherals, like what are the peripherals you want, and what are based on the power consumption, whether it is going to be battery operated, what is the power consumed by the FPGA, that based on supply reputation. So these are things which you have to consider while you choose a processor, specifically an FPGA, while you design an embedded system design. Okay. So tools we'll be using Xilinx ISC and Xilinx XPS Platform Studio, and Vivado, okay, and Python, we'll be using a board called Pink for Python productivity for Zinc to deploy a Python code on FPGA, as well as to run machine learning applications like YOLO applications and OpenCV applications, how to implement OpenCV applications on an FPGA. These are the tools which we'll be learning. Okay, so so thank you so much. Thank you so much for your time. So we'll be thank you so much. Thank you for your time. So we'll close the session within the next 5 minutes. So before that, I have an announcement. Like if you want to enroll for the internship, the price will be around 750 rupees plus GST for FPGA. Okay, where you can download the source codes. Okay, so PPT I'll share you through email. Okay, but source code will not be source code is not shared. But by going through the video, definitely you can replicate the same thing. Okay, this 21 days is free for you. By going through the source codes on the videos, it can be replicated. You can make it up, and you have Q&A. It's only on this YouTube, whereas the internship candidates, you have Q&A on live and forum, and community. You have access to the community for lifetime. Okay, and bonus live sessions on every week, like how to design an FPGA and everything. And hackathon, you have weekend hackathons, like 3-hour sessions, hackathons on Zoom platform. So the pricing is 750 rupees plus GST. Okay, if you want to enroll for FPGA. So so we have a big announcement, like the combo offer. If you want to know about combo offer, just type yes in the chat box. If you want to know about combo offer, like I'll give you a combo offer where we have embedded system design and IoT masterclass for 30 days. Okay, where we cover up 5 architectures: the 82 architecture, the PIC architecture, the ARM7 architecture, and LPC architecture, and Node MC architecture. The pricing is 999 rupees for this 30 days. Okay, and the IoT masterclass series, where we cover up ThinkSpeak platform and Microsoft Azure platform and AWS platform, which is for 30 days. Okay, using ESP32. So it is 999 rupees. And the embedded C programming, if you want to start up with the basic C language, then we have embedded C programming, where it's a 30-day series, which is for 999 rupees. Okay, and we have a PCB design masterclass, where we teach you how to design a microcontroller board and how to design an FPGA board. Okay, so that is for 499 rupees, and FPGA masterclass for 30 days, it's 999 rupees. Okay. So today, I'm going to give you 5 offers. Okay, the combo offer, 5 courses on a single offer. Okay, so the price is 999 rupees for all these 5 courses. Okay? And the validity is lifetime. Apart from this, you have access to the community. Okay? I'll show you what is there in the community. In community, we'll be having live Zoom sessions on every week on the Entrepreneurs Corner as well as on the hackathon sessions. Okay? So this is what you get at 999 rupees. You have 130 days of learning. Okay? You can design your own 2-layer microcontroller board and FPGA board using Cadence Allegro, and lifetime community access, okay, coaching on mindset, technicals and soft skills, and entrepreneurs coaching, and 5 internship certificates, okay, and you have hackathons on every week, okay, and you have VIP Telegram group for 30 days challenge. So this is what you get at 999 rupees. So thank you so much for your time. The attendance form will be on the chat box. You can fill the attendance form. Meantime, I'll take the Q&A. Okay, I'll take the Q&A, and this offer is valid only for 30 minutes. Okay, this offer is valid only for 30 minutes. So the attendance form will be there on the chat box. I'll take your questions. So please do post your questions on the chat box. I'll take your questions. Okay. Okay, I'll start this timer. Okay, so I'll take your questions now. Can you post your questions on the chat box? PPT, like I'll send through email. Okay, so attendance link is there. Attendance link is there on the chat box. For international, we will provide a link. We will provide the international link through the email. Please do check. Okay. Kevin is asking like difference between the SoC and FPGA. Okay, system on chip and FPGA. See, system on chip is nothing but having more than one core. Okay, you can have 2 cores or having more than 2 cores, like 2-core processors or 4-core processors, and all the peripherals will be there inside the on the SoC. Okay, you can have SoC inside an FPGA. You can also have SoC inside an FPGA, and you can customize according to your own use. Okay, that is the advantage. Kevin, you can customize. Whereas on a SoC, like if you take an ESP32, the core inside the core inside the SoC cannot be customized. Okay, the ESP32 like 10 silica core. It is based on 10 silica core. Extensor core, like you cannot customize this one. Whereas in FPGA, you can customize the integrated circuits. The user can customize. Okay, so that is the advantage. Kevin, what is the difference between ASIC? What is the difference between Verilog? Currently, we don't have plans for Verilog. Samir Sharma, like we have. You wait for an update. Maybe soon we will release an Verilog. Okay. So difference between ASIC and microcontroller. Giridhan, like ASIC stands for application specific integrated circuits. These are integrated circuits which is meant only for that application. Okay. Whereas microcontroller, you can use it for any applications. For example, you want to implement a simple door lock, you can implement. If you want to implement a home automation, you can reprogram with some other codes. Whereas in ASIC, you cannot do that. It is meant only for that application. Okay. One example of ASIC is we have a product called BrainSense. Okay, BrainSense, which sends the brain waves from the which sends the EEG signals from the brain. Okay, which uses a module, ASIC module, TGM ASIC module, which is from a company called Neurosky. You can search for TGAM. Okay, let me show this. So, this is one example for ASIC module. Okay, EEG TGM. So this chip is an ASIC. Okay, this chip is an ASIC where you can interface EEG sensor, and you can the Neurosky company has the proprietary algorithms for attention, for meditation, to measure the attention levels of the children's and meditation levels. Okay, so we have developed a headband based on this ASIC module. Okay, ASIC module, like which is used to improve the productivity. Like you can increase the focus. You can even for home automation, if you want to control the home through brain, you can use this ASIC module. Okay, so this is one example for ASIC module. But you cannot write a program for you can write the program for application, but you cannot write the program for that chip. Okay, so this answer is for Giridharan. So Yes, the Manjunath, the PCB design class will be starting this week, like the FPGA master class. I was waiting for this. Like this week, we will be having a schematic design of FPGA. We'll be updating that on the portal. Okay, we'll be updating updating on the portal. Like we'll start schematic design of like you can go for the community. Like I'll show you that. Okay, we will have the schematic design this week. Footprint. So it records nearly 3 sessions. Okay. Uh, so one session we'll have for schematic design. So so it is okay. This week we will have. So these are the events which you can have it on the community, like how to create Google Ads, machine learning, your object recognition. Okay. So these are the past events which we have conducted. Project on unsupervised learning. Okay. AI using MATLAB part 2 and part 1 we have completed. So how to design a two-layer PCB hackathon we have completed. Design a FPGA board. We have completed the basic, like how to design, what are the components, what are the peripherals there in FPGA board. So this week we will have how to do the schematic design, like what are the like how to create the schematic library. Okay, this answer is for Manjunath. So once you enroll, you will get access to this community, like where you can have sessions. You can also attend sessions from artificial intelligence. We used to conduct sessions on two major areas. One is on embedded system design, the other is on the artificial intelligence. Okay. So I think last Saturday we have session only from the artificial intelligence. I have not conducted any sessions because the previous session we have it on both Saturday and Sunday. We have session on MATLAB, AI using MATLAB part 1 and AI using MATLAB part 2. So all these are 3-hour sessions. This recordings will be available only for the gold membership. Okay. So you are free to attend any sessions. You are free to attend any sessions like on Zoom platform. And this is lifetime. Okay, this is not limited. Like you can whatever the programs we have programs on the entrepreneurs corner, like where you can start up your own startups, and how to run Facebook ads, how to run a YouTube channel. Okay, and how to create and sell courses, and how to do LinkedIn mastery. Okay. These are soft skill sessions, how to write your resume. So all these sessions you are free to attend. If you want recordings, then it will be available only for the gold membership. Okay. So any questions? Okay. So the attendance link is there. On the chat box. Please find the attendance link there in the chat box. Okay. Saurav Singh, the PCB details. Please share the details of PCB class, like the PCB. Let me show you the PCB class. Okay. Okay, so the basic PCB design course what we have has the 80 microcontroller board. But if you have the hackathon series, the hackathon which is conducted on the portal, like we have designed an 80 board, we have designed an IoT board. Okay, and we have designed a simple two-layer PCB on how to create 3D models in Jabber. Okay, so you can get access to the recordings. You can download all the resources, like the schematics, symbols, footprints. Okay, everything you can download. How to design an FPGA board. So only part 1 has been conducted now. So this has part 1, part 2, part 3, and part 4. Like totally, like as like IoT board, we have part 3. So we here, like we'll have schematics. If you enroll for an internship for 999 rupees, you are free to attend any hackathon sessions, but the recordings will not be available. Okay, the recordings is available only for the gold membership. And the PCB design course is based on the Cadence Allegro. We have plans to come up with KiCad. Okay, so which will be released, you will have an update on the community once we release that one. Any questions? I'll take the questions. what is IP? Like Somnath is asking what is IP. Okay, IP stands for intellectual property, like IP cores. I'm talking about the IP cores. These are all pre-written behavioral codes, okay, which you can pay license. Sometimes IP cores are free. Sometimes the IP cores or you have to pay a license fee for this. For example, if you want to implement a PCI controller, like the peripheral component interconnect peripherals inside an FPGA, the basic IP cores like the SPI serial peripheral interface I2C will be free. You can use it from the software. But some complex peripherals you have to pay license for Xilinx. Okay, so these are pre-written behavioral codes or Verilog codes. You can choose anything, what are the options which you want. Okay, and you can integrate that with the FPGA. This answer is for Somnath. Okay, FPGA selection methodology. Okay, Kevin, like you just I wanted to go through first you choose FPGA selection methodology. Okay, let me. So based on the IOs, okay, and based on the applications, like so. Okay, so based on the development tools, like based on the applications and based on the number of IOs, okay, and the performance, what kind of performance you want, and based on the cost, because some FPGAs are optimized for IOs, some FPGAs are optimized for transceivers, high speed transceivers to interface with high speed ADCs and DACs, and some FPGA are optimized for the complex SoC application. Like Zinc is optimized for complex SoC applications, where you can implement a complex artificial, even you can implement the machine learning applications and AI applications. You can put it on Zinc platform, and based on the cost and based on the operating systems you want. Okay, some FPGA will support only Linux. They will not support the operating system which has a virtual memory, whereas some FPGA will support an operating system which needs a virtual memory. Okay, like the Windows based operating system, like the Windows CE, they need a virtual memory for. So in that case, you have to choose. You have to go through the data sheet of DigiKey in digikey.in, or you just go for the website. Once you choose the manufacturer, okay, once you choose whether to go with Xilinx or whether to go with Altera, you go through the families. You go through the families of FPGA. Each families are meant for some specific applications. Okay, you go for the application nodes, and you can choose like based on the customer requirements, the software, the hardware requirement specification, or from the software requirement specification, and you match it with the portfolio of the vendors, manufacturers, Xilinx. Okay, you can use DigiKey for this, and you can also use the support team from Xilinx. They will also recommend, like once if you give the if you give the software recommend specification to Xilinx, they will also recommend the right part for this. Okay, and peripherals, like what are the peripherals which you want, and whether it is whether the IP core is free or whether it is licensed. Okay, and based on the power consumption. So these are the process selection criteria. Okay? These are the process. This answer is for Kevin. Giridhan is asking, is IoT is an embedded? Is IoT is an embedded? See, Internet of Things, embedded system design is anything which does a specific application is an embedded system design. Okay, you can implement an IoT applications in an embedded. You can use an embedded system design for an IoT applications. Okay, which is going to perform a specific task. Okay, for example, you take the Fitbit or any wearable device, which is still an IoT device, as well as, and it is also an embedded device. Okay, if you want to define embedded systems, these are systems which do only a specific task. Okay, it may have a combination of hardware or software or with some mechanical parts to perform only the specific task. Okay, so that is an embedded system. Okay, so okay, I'll try to go slow. I'll try to go slow, like Mohammed. Okay. No, internship, it's not even for gold. You can even for the one for 999 rupees. The advantage of going with internship is you get access to the source codes, you get access to the source codes, you get access to the community. The best thing is the community part. Okay, where you have the continuous learning process, and you can watch the video at any time, because the video from YouTube will be removed after 3 to 5 days. So all the courses will have like it's lifetime validity. The courses is lifetime validity, so you can access. And the community, the best part is community. So we will be updating the community like with various new sessions like every time. So you're free to attend. The only thing is you will not get the recordings for that community. Okay, so if you can come and you can attend, and you can, if you want recordings, then that is available only for the gold membership. This answer is for 82 lab programs. After 130 days, you can access. It's lifetime. Harshit, this is lifetime validity. It's lifetime validity. Okay. Pradeep, how FPGA takes image because VHDL Verilog not support image formats. Okay. You can implement see by image, like you can interface a CMOS image sensor. If you want to do a real-time image processing, you can interface a CMOS image sensor. Else you can give like the edge detection. How the way which we have implemented is using C language, where the pixel is, where the image is converted to a pixel by using a tool called MATLAB. Okay, and we'll be using this and the header file. Okay, if you want to do that on a real time, it is possible. You can also do it on VHDL also. VHDL, it is possible to interface with the camera and get the values directly from the camera, and you can store it on the memory, and you can process those images. This answer is for Pradeep Kumar. Okay. Giridharan, I have answered your question. Like Praveen is asking, is what kind of applications DSP still used? If applications for DSP, will FPGA be more expensive? Yes. See, based on the applications, you can choose FPGA or DSP. Okay, because DSP processor you can get for 300 rupees, but there are some FPGAs which will cost you even for 20 lakh rupees. Okay, it depends upon this type of system which you design, whether it is a hard real time or soft real time. There are two types of real-time systems. When you go for designing a real-time systems, there are two types of real-time systems. One is the hard real-time, the other is the soft real-time. Hard real-time means if the system misses a deadline, okay, then you may get a havoc, like a nuclear reactor. Okay, if some alarm fails, then it may destroy a lot of lives. Okay, the aircraft. These are hard real-time systems. Soft real-time systems, your music player is a soft real-time system, your gaming device is a soft real-time systems. Missing a deadline may degrade the performance of the system. Okay, in that case you can go for DSP processor, for low-end processor, where you don't want to put more money on this. Okay, so more money on this, like audio device. If you take an audio device, okay, audio or DSP processors like MP3 players. One example is MP3 players, or DSP device. Okay, so these DSP devices are now these DSP processors are now they're coming with SoC, like having more than one core inside the package. Okay, not to compete with the SoC market, and not to compete with the FPGA market. All these are competitions which is happening inside the manufacturers. They don't want to miss the market. Okay, that's the reason why the microcontroller manufacturers, they come up with the DSP capability, like the ARM core, the ARM 7 core, they have DSP. The TDMI stands, the D stands for DSP. Okay, it has DSP capability. You cannot compare with the traditional DSP processor, the high-end DSP processor, but still you can do a simple DSP applications. Okay, the ARM 7 TDMI and the ARM 9 Cortex M4 also has a DSP capability. System on chip. SoC. SoC is nothing but if you check out. Let me show you one slide. I think this is for Giridharan. Let me show you one slide for. Okay, so if you check out this SoC, okay, you have the CPU, you have the CPU, you have central processing unit, you have the graphic processing unit, okay, NPU for neural processing unit, and you have DSP processing unit, and ISP for image signal processing unit. Okay, so you have multiple processing units inside a single package. That is an SoC. If sometimes you can, the capability can be a microprocessor. If you take a Broadcom chip, the Broadcom chip has a microprocessor which with an SoC package. Okay, the chipset from the Raspberry Pi is an SoC. The chipset from the Raspberry Pi is an SoC, but the processor is a microprocessor. The reason I said microprocessor is because of its expandable in nature. Okay, as microcontroller it is limited. Microprocessor it is expandable. You can expand the capabilities. Okay, so this answer is for Giridharan. Google, we don't have class for embedded driver development. Like I think the next class you can expect after 6 months. Okay, I think even this FPGA master class we have conducted previously before 1 year back. Okay, so like the next series is on embedded system design using ARM Cortex M4. Okay, which is a 30-day series, and we have machine learning, which will be conducting on the next week. Okay, machine learning using Python. So if you want to learn machine learning, you can learn this. Okay. So we have only 11 minutes. Okay, the gold membership is 9,999. I think 9,999 plus GST. Okay, 10,000 plus GST. So if you like, you can wait for offers. If you want offers, like you can wait for offers during the Christmas times and the Black Friday offer. You will get Black Friday offer. Okay, the gold membership. This is for Oscar rules. Okay. Marcelo, like I think we have provided the international card payment. Okay, you can check out this international card payment. Is there any questions? Any questions? If you have any technical questions, I'll take how FPGA takes image. I have answered this. Any questions? Just put it on the chat box. Ishan, like yes, we are selling FPGA boards. We are selling FPGA boards, but we have to check stock because there are a lot of the market is very down. The chip market is very down from China as well as from US. Okay, so it's very hard to get chips nowadays. Like the Texas Instruments series, the products what we have series, the series what we have is currently out of stock, and it is expected at January or February. I think it is expected from January, February. Please do drop an email to info@pantechsolutions.net. We will check if the stock is available. Like we can ship the product. Okay, FPGA kit. Because the most of the customers are from engineering colleges. They used to wait for 2 to 3 months of time where they will be placing like 10 to 20 boards of FPGA boards. Sometimes they used to purchase 5 boards, sometimes 10 boards, sometimes 20 boards. It depends upon the college. Okay, so very rare case like the students they will purchase. But we have the I'll show you the list of boards which is available on Pantech. So these are the boards. If you want to design this board, if you want to design this FPGA board, we have program to design this Spartan 6. We are planning to design a Spartan 6 FPGA board on the hackathon series. One session has been completed. Okay, so we will teach you exactly how to design this board. Okay? So sorry. So how to interface like the LEDs, switches, relays, and UART. Okay, so SPI ADC and SPI DAC. So okay. So, but this session is a prerequisite session. I think we have already completed the prerequisite session, like how to design a 2-layer PCB. It is a must session. Only then you can understand this. Okay. So please do, if you have already enrolled for internship, please do sign up for the community and get the details like from the community, and we'll have session. It's okay. So any questions? Any questions? FPGA programming software. You can use Xilinx ISC. Okay, you can use Xilinx ISC like Manjunath. FPGA programming software. You can use Xilinx ISC or you can use Vivado. Like you can program by using JATAC. Okay, there is no. If you want an USB programming facility, then the USB they have to program the bit file. Everyone has a separate file. Okay. But if you use a parallel JTAG or if you use a JTAG from the Xilinx, like the normal programmer from the Xilinx, then you can use Xilinx ISC or from the. Okay, okay. So Karthik, thank you, and okay. Giridharan, like mobile phone contains only SOC. Okay, Giridharan mobile phones contains only SOC. SOC, SOC. Okay, especially from companies from Snapdragon, you can check the specifications. Okay, okay. So the attendance link is there. Attendance link is there on the chat box. You can find out and you can sign up for the attendance. Okay. Any questions? Any questions? We have 6 more minutes. We'll close the session with 6 more minutes. Okay. Lalit Madhav is asking, is there any scope of good position based on embedded systems in future? Definitely, like you can because if you take electronics, if you find out any devices in your home, you can see the electronics. Okay, so all these are embedded systems, and the future is going to be the embedded systems. Like you can implement artificial intelligence on embedded system design. You can implement Internet of Things on embedded system design. So which the IoT plays a major role, major applications, because we all produce data. Okay, so these data can be collected and can be analyzed in an effective way. Okay, so IoT devices will, if you take your home, like we have 4 to 5 smartphones. We have smartphones for everyone in the home, which produces a lot of data, like how many distance you walk, where you go, what kind of shops you visit, what kind of things you browse. Okay, all this information is collected, and you can use it in a meaningful way. Okay, like how to reduce the calories, and where you are, like using GPS you can identify where you are, you can share the locations. So all these are Fitbits. Okay, Fitbits and smart TVs, all these are embedded systems. So IoT, if you work on yourself more, like the money you make here is more. Okay, you should learn artificial intelligence, you should learn embedded system design on various architecture. You should learn C language, Python programming. Okay, if you want to become a embedded system design software engineer, like you start with C language, you also learn Python language. Okay, and you also learn MATLAB and OpenCV, and you learn the architectures, Egyptian architecture, PIC architecture, ARM architecture, Cortex M4 architecture, and FPGAs. You learn FPGAs and DSP processors. Okay, okay. So over the period of time, like 2 years to 3 years, you learn on a daily basis. Over the period of time, 2 years to 3 years, definitely you will be an expert. Okay, so once after 2 3 years, so that once you become irreplaceable, then you can ask for a higher pay, like uh, you will get a higher pay, or you can even start up a company. Okay, and you can share your knowledge with others, or you can solve some problems by your products or services. Okay, so more you work on yourself on any area, not only on embedded system design but any area, but still embedded system design has a very good area. Okay, this answer is for Lalit. Okay, so is there any questions? How can we do projects with FPGA? Any suggestions? Okay, if FPGA is very good, Kadir, it depends upon the FPGA which you choose. Okay, if you take the FPGA development board, you can get from 5,000 rupees to like 15,000 rupees, 20,000 rupees. Okay, the Zing series you can get for 16,000 rupees. If you take a normal board, you can get for 4,500 rupees the FPGA board. Okay, you can check out in Amazon. You can check for the FPGA boards. If you are implementing a simple microcontroller applications, then you can choose a board for 4,500 rupees. It works fine. Okay, if you want to implement an AI application, then you have to go with a Zinc based board. uh, that will cost you like 15,000 to 17,000 rupees. Okay, this answer is for Kadir. Giridharan, like I have answered your question, like FPGA is used in mobile phone instead of SOC. FPGA is not used in mobile phone, only SOC is there. Okay. So I want to know about ARM processor. ARM processor, like we have a series on 30-day series which is coming this month end. Okay. Kadir, I have answered your question. Okay. So thank you so much. Thank you so much for your time. Uh, So see you on the next session tomorrow. Okay. Until then, bye bye. Take care. So the offer ends in 2 minutes. Okay. So please do sign up for the offer. After this, the offer will be closed. So thank you so much for your time. Okay. Yes, Rajshekhar, yes, we have plans to update the content. Okay. Definitely, like we'll be include. The boards the Python is based on the last 2 days. We have used Python like the Zinc series. We have used Zinc series and we have used Spartan 6 series. Okay. Definitely, like we will go with the Spartan 7 or Arctic 7. Okay. I will update, but this series is all about Spartan 6. But we have planned to update for Spartan 7 series and the Zinc series. Okay. So thank you so much for your time. See you on the next session tomorrow. Until then, bye bye. Take care.